everyone, and welcome to the fifth chapter of our Chemistry O-Level lesson series. This chapter is called Elements, Compounds, and Mixtures. Here we have the learning objectives of this chapter, and as you can see, we only have 3 learning objectives. You can find the specific topics of this chapter in the description below, along with their timings. So, in this chapter, we should be able to define an atom and a molecule, define elements, compounds, and mixtures, and list the difference between mixtures and compounds. So this is all you have to do in this chapter. It's a very small chapter with the least learning objectives compared to any other chapter we've done so far and we're going to do in the future. So let's begin this chapter by first understanding elements and atoms. So the world we live in is made up of millions of different substances. However, all of these substances are made up of fundamental material called elements. So, here we have the definition of elements. An element is a substance which cannot be split into 2 or more simpler substances by chemical means. Okay? It's the basic substance basically. It cannot be split into anything else. Like we see the periodic table of elements. It has all the elements, and these elements are the substances which cannot be split into simpler substances. Okay, so it's very simple. Elements are made up of atoms. Atoms of a particular element are identical to each other but different from all other elements. They're completely unique. So every element is different from another element. So an atom is the smallest possible particle of an element that can take part in a chemical change. It is the smallest possible particle of an element. So, let me just give you an idea of how small an atom is. If atoms were placed in a straight line touching each other, then 2 million atoms would be needed to cover a full stop. You can see this little full stop here. 2 million atoms would be needed to cover this full stop if they are arranged in regular lines. So, a straight line of 40 centimeter length and assumed to be 1 atom thick would contain more atoms than there are people in the world. If 1 million atoms were allowed to escape through a hole in a balloon in a second, it would take nearly 1,000 years for the balloon to empty. And right now, take a deep breath in. You have just breathed in approximately 100,000 million atoms. So, these are the amazingly small atoms that we're talking about here. The atom is the smallest possible particle of an element that can take part in a chemical change. So here we have a list of different elements along with their symbols. So first we have hydrogen. The symbol of this element is capital H. Helium, the symbol of this element is He. Lithium, the symbol is Li. Beryllium, Be. Boron, B. Carbon, C, nitrogen, N. And whenever we are writing the symbols, if it is a 2-letter symbol, then the first letter is going to be capital and the second one is going to be small. And if it's 1 letter, then it will always be capital. Neon, Ne, sodium, Na, magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, sulfur, S, chlorine, Cl, argon, Ar, potassium, K, calcium, Ca, scandium, Sc, titanium, Ti, and vanadium, V. These were some of the first elements of the periodic table. So the most common elements in the air are nitrogen and oxygen. Nitrogen makes up 78% and oxygen makes up 21% of the air. In the Earth's crust, the most common is oxygen, which is 46.6%. Then we have silicon, aluminium, iron, and calcium. So together, these make up over 90% of the Earth's crust. So basically what I'm trying to tell you is that elements are present in both living and non-living materials. And there are many elements that are in different materials, causing them to have different types of textures and different types of properties. Like a brick is different from ceramic because the main elements of both the materials are different. In ceramic we have sodium, potassium, aluminium, silicon and oxygen, whereas in the brick we have oxygen, silicon, calcium and carbon instead of potassium, sodium and aluminium. Oxygen and silicon are present in both, but in a brick, calcium and carbon are also present, and in ceramic, aluminium, silicon and oxygen is also present. A car's main elements are iron, aluminium, carbon, chromium and nickel. These are non-living things. Then we get to living materials like a tree. The main elements of a tree would be oxygen, hydrogen, carbon, nitrogen and phosphorus. In humans, the main elements are hydrogen, oxygen, carbon, nitrogen and calcium. So that's what I'm saying, that elements are present in every single thing that is around us and that we are made of. Our entire body is made up of elements. So now that we've understood elements and atoms, we're going to move ahead onto molecules and compounds. So when atoms join together, they form molecules. But of course, we said that the element is a substance which cannot be split into two or more simpler substances by chemical means. But a molecule can be split into two or more simpler substances, which means that a molecule makes something that can be split into a simpler substance. That means that a molecule would not make an element. An element can only be made by an atom. A molecule is the smallest particle of a compound and is made up of groups of atoms. So, this is the smallest particle of a compound. What is a compound? A compound is a pure substance which contains only one type of molecule made up of atoms of more than one element. So elements and atoms are total different things from molecules and compounds. Elements are substances which cannot be split into simpler substances by any chemical means, and elements are made up of atoms. These atoms are the smallest possible particle of an element that can take part in a chemical change. So, atoms make elements, and every element has its own different and unique atom. But compounds are made up of molecules, and molecules are made up of atoms. Okay? I think you understand my point, that molecules can be split into simpler substances, but an atom cannot. A molecule can be split into atoms. So what we are saying here is that an atom makes an element, and an atom also makes a molecule. So two atoms of elements join together to form a molecule. Molecules are made from atoms, and two atoms of different elements or the same elements would join together to make a molecule. So a molecule is made up of atoms. So this can be split into atoms, whereas an atom is the smallest particle and this cannot be split into anything else. Then we have compounds, which are made from molecules. But a compound contains only one type of molecule, not two different types. A compound would contain only one type of molecule. For example, water. Water is a compound whose molecules have a formula of H2O. And so, water does not have any other molecules except for H2O. This means that a molecule of water contains 3 atoms in total, 2 of which are hydrogen and 1 oxygen. Here we have the elements, the element hydrogen and the element oxygen. These are the 2 elements, and the atoms of these 2 elements join together in different proportions to form a molecule. And then many of these molecules would form a compound. I hope that's clear. So in water, we have the proportion of H2O. This means that we have 2 hydrogen atoms and 1 oxygen atom, which forms water. So to show the atoms present in a molecule of a compound, we use its chemical formula. Like water has a chemical formula of H2O. In the same way, we have many other chemical formulas like carbon dioxide gas. This has a chemical formula of CO2. So it has molecules which contain 1 carbon atom and 2 oxygen atoms. Atoms of elements in different proportions join to form a molecule, and many of these molecules form a compound. But remember, a compound is a pure substance which contains only one type of molecule. Okay? Remember, if it has different types of molecules, it will be called a mixture. A compound is a pure substance. We're going to see what mixtures are in more detail later on, but let's understand the chemical formulas. Methane gas has a chemical formula of CH4. So it has molecules with 1 carbon and 4 hydrogen atoms. Here we have some other substances and their formulas. Chlorine gas has Cl2, is written as Cl2. Even though chlorine is an element, you should know that in the periodic table we see chlorine as an element, Cl. But why is chlorine a compound here? Because chlorine gas is made up of two chlorine atoms joined together. So this is a chlorine molecule. A chlorine atom is different. That is written as Cl only. But if we write Cl2, then we're talking about the chlorine molecule. Two chlorine atoms join to form a chlorine molecule. The same is with the oxygen gas. Oxygen itself is an element, but the gas is a compound. It's because two atoms join to form this. So compounds contain one type of molecule. If they are similar, they would be called with the same name. Like oxygen gas has two similar atoms of oxygen. That is why we call it oxygen gas. The same is with chlorine. The same is with nitrogen here, as well as with hydrogen. So we do have elements, hydrogen, nitrogen, oxygen, and chlorine, but we also have molecules of these, which are different from elements. Chlorine is a molecule as well as an element, but they are total different things because the chlorine element is made up of only atoms of chlorine, whereas the compound chlorine is made up of chlorine molecules, which in turn are made up of chlorine atoms, two chlorine atoms. Here we have chlorine gas, oxygen gas, nitrogen gas, and hydrogen. Then we have methane gas. This has a chemical formula of CH4. So it has one carbon atom and four hydrogen atoms. Here we have ammonia. This is NH3, one nitrogen atom and three hydrogen atoms. Carbon dioxide CO2 and water H2O. As you can see, their chemical formulas represent the number of these atoms. So when we say CO2, you should understand that the C is 1, and when we have a number after the element name, that would be the number of atoms of that element. So if we say CO2, then the carbon atom is 1 and the oxygen atom are 2. If we say NH3, the N atom, which is the nitrogen, is 1 and the hydrogen atom is 3. So as you can see, because these compounds are made up of two different types of atoms or three different types of atoms, in this case these are only two different types of atoms, they have total different names like methane, ammonia, carbon dioxide, water. We do not find these in the periodic table. So remember, these are two different types of molecules. These are molecules of elements and these are molecules of compounds, because they are made up of two different types of atoms, nitrogen and hydrogen. But in the chlorine, oxygen, nitrogen, and hydrogen case, we have molecules with the same types of atoms together. So that is why we call them chlorine, oxygen, because they have atoms of the same element, but still they are molecules. These are also molecules, methane, ammonia, carbon dioxide, and water. These are the molecules of these compounds. So lots of methane molecules, these CH4 atoms, would make a compound, which is methane. Lots of ammonia molecules would make a compound, which is ammonia. Many carbon dioxide molecules would make a compound called carbon dioxide. So a compound is a pure substance which contains only one type of molecule. A molecule is the smallest particle of a compound and is made up of groups of atoms. The atoms are the smallest possible particle of an element. An element is a substance which cannot be split into two or more simpler substances by any chemical means. The element is the end. So, what I was explaining here about the chlorine, oxygen, and nitrogen and hydrogen gas, there are elements which consist of molecules, like these. Like oxygen is made up of molecules containing two oxygen atoms joined together. It is the same for chlorine gas, nitrogen gas, and hydrogen gas. So such molecules are said to be diatomic. That's what we were going to remember. The molecules which are made up of two atoms of different elements of the same element. So they are said to be diatomic. Like hydrogen is made up of two atoms of the same element, which is hydrogen. That is why this molecule is also called hydrogen. If it was made up of atoms of different elements, then it would have a different kind of name, like methane, ammonia, carbon dioxide, water. These are different names which are not found in the periodic table because these are not represented by a singular element, whereas these molecules are represented by a singular element as well, like oxygen, nitrogen, and hydrogen because they are made up of atoms of the same element. So such molecules which are made up of two atoms are said to be diatomic. So now we're going to move ahead on to understanding the difference between mixtures and compounds. So a compound is formed when two or more different elements are chemically combined together. So remember, these are chemically combined together. A compound is formed when two or more different elements are chemically combined together. So here we are saying that it is made when two or more different elements are chemically combined together. So remember, these molecules are different from such molecules. These molecules are molecules of elements, whereas these molecules are molecules of compounds. So molecules which have two or more different elements can make compounds. These molecules cannot make compounds because they are made up of the same element, of only one element. So these are said to be molecules of elements, and these are molecules of compounds. I hope it's clear. So a compound is formed when two or more different elements are chemically combined together. So a compound is a pure substance. What we read here in the beginning, that a compound is a pure substance which contains only one type of molecule, made up of atoms of more than one element. This is the best definition of a compound. What we're saying is that a compound is a pure substance which contains only one type of molecule made up of atoms of more than one element. So, a compound is made up of only molecules which have atoms of different elements, of more than one element, okay? Not a single element, not one element. We need more than one element, like methane, ammonia, carbon dioxide, water. But a compound is a pure substance because it is made up of only this one molecule. The molecule is made up of different atoms, but the compound is made up of only this one molecule. It doesn't have different molecules. So what I'm saying is that if methane and ammonia are mixed together, that would not be a compound because we have two different molecules, methane and ammonia. These are two different molecules. A compound is a pure substance. Why do we call it a pure substance? Because it contains only one type of molecule. So that's what I'm saying, that a compound is made up of only one type of molecule, and this molecule has to be made up of atoms of more than one element. Okay? I hope that's clear. But on the other hand, a mixture is not a pure substance because it contains a mixture of atoms and/or molecules which are not chemically changed. So a compound is formed when these elements are chemically combined together. By chemically we mean that they are heated. There is some sort of chemical change. But in mixture we only have a physical change, not a chemical change. We do not heat things in mixtures. If we heat them, they will become a compound. And a mixture is not a pure substance because it contains a mixture of atoms or molecules. It may contain the carbon dioxide molecule as well as the ammonia gas molecule together and some different atoms. Or it may be a mixture of different atoms of different elements like nitrogen and hydrogen. We mix them together, and so that would not be called an element, that would be a mixture of elements. So a mixture is not a pure substance because it's not made up of only one atom or one molecule. It contains a mixture of atoms or molecules which are not chemically changed. Remember, a mixture can also be formed of atoms as well as molecules together. And it can be formed with only atoms of different elements, and it can be formed of only molecules, different molecules, and not atoms. So a mixture is completely free. It can be made up of anything at all until and unless they are chemically changed, and until and unless it remain pure. By a pure substance, we have read this in the previous chapters as well. A pure substance is made up of only one molecule or one atom. So a single element is pure because it is made up of only one atom. In the same way, a compound is pure because it is made up of only one molecule. But a compound would not be pure if it is made with different molecules. In the same way, an element would not be pure if it is mixed with another atom of a different element, no matter the quantity or the proportion of the other element or molecule. So the difference between a compound and a mixture is that a mixture is not pure whereas a compound is pure. A mixture can be made up of anything at all. Different kinds of molecules together, different kinds of atoms together, different kinds of atoms and molecules together. So a mixture can be made up of anything at all, whereas compounds are made up of only one molecule. And a mixture is not chemically changed, whereas a compound is chemically changed, because to form a compound, two or more different elements are chemically combined together. By that we mean when molecules are made. So because a compound is made up of only one molecule, that single molecule is made up of atoms of more than one element, which are chemically combined together, which means that they are heated together. So a mixture can sometimes be changed into a compound as well. For example, if iron filings, which are iron, and sulfur powder are mixed together, this is sulfur, the iron atoms do not join to the sulfur atoms, so no new compound is formed. The mixture can be separated easily by physical means, such as using a magnet to attract the iron filings away from the sulfur. However, if the iron and sulfur are heated together, the energy supplied is used to join the iron and sulfur atoms together to form a compound called iron 2 sulfide. This is what I was talking about, that mixtures are not chemically changed, whereas compounds are chemically changed. So this compound, iron 2 sulfide, has properties different from those of the individual elements of which it is made. So when new compounds are formed, we say a chemical change has taken place. Here is what happens when iron 2 sulfide forms. First, these were two different elements, iron and sulfur. They got mixed together, but when they got mixed together, we wouldn't call them a compound, and so that would be called a mixture. And remember, a mixture can be separated easily by physical means. Like in this case, we used a magnet to attract the iron filings away from the sulfur. But if the sulfur and iron mixture was heated together, then that heat would cause the two atoms to join together to form a different molecule, hence a compound, iron sulfide. So when a molecule is formed, a compound is formed at the same time. Okay. Right now we're talking in a smaller aspect. One iron atom and one sulfur atom fuse together. When they are heated together, form a molecule of iron sulfide. But usually there are billions of iron atoms and billions of sulfur atoms which join together to form billions of iron sulfide molecules. So in that case, if there are billions of the same molecules, that would be called a compound. Okay? So this is what I was talking about, that a mixture is not chemically changed. A mixture is just a mixture. We mix salt and water together, but because we do not heat it, it is not a compound. We just mixed it together, and so that is why it can be separated as well. This mixture can be separated, the salt and water. We saw in the previous chapters how mixtures can be separated. In that, I did not talk about compounds, because we cannot separate compound by physical means, such as in this case we used a magnet, in other cases we use other methods. But the mixture can be separated easily by physical means because it is not heated. It is still two different elements. Iron is still iron and sulfur is still sulfur. But if this mixture is heated, then the iron and sulfur are completely joined together. They are joined together and then they no longer remain sulfur and iron. They become iron sulfide. Then we do not have two different atoms. We have one single molecule. So, a mixture is not a pure substance as it contains a mixture of atoms or molecules which are not chemically combined. So let me give you some examples of mixtures. Alloys, for example, are mixtures of different metals. Certain coins in some countries are made of the alloy aluminium and bronze. Aluminium, bronze. And so, alloys are mixtures of metals. These metals are mixed together. Three different types of metals are mixed together to form an alloy. Remember, they are not heated. If they get heated, they are formed into something very different from what they are actually. So remember this as well, that when two elements are mixed together, not heated together, mixed together, they form a mixture. And a mixture contains properties related to the atoms it is made of. Like iron and sulfur are mixed together, they would have the properties of both iron and sulfur. If iron is blue in color and sulfur is purple in color, just as an example, when they are mixed, they form a color which contains both purple and blue. So when we mix purple into blue, we get a different kind of color. And so that color is related to both of these. It is made up of these. But if we heat iron and sulfur, we get a total different color because these two are no longer iron and sulfur. They become iron sulfide, which is a total different thing. And iron sulfide doesn't have any properties similar to sulfur or iron, whether it's the color or the texture, the molecular arrangement, or anything else. Okay? So the physical properties of mixtures are an average of those of the substances in it. But the physical properties of compounds are individual and not the result of its elements. Okay? So I was talking about some other mixtures, like in mixtures we have solutions as well. Like fizzy drinks are mixtures of water, colorings, sweeteners, and carbon dioxide gas. Air is a mixture of gases. It contains mainly nitrogen gas and oxygen gas, with small amounts of inert gases like argon and helium, traces of carbon dioxide gas, and water vapor. Seawater is also a mixture. This is a mixture of dissolved solids and water. The main dissolved solid is common salt. And this can be separated, Mixtures can be separated easily, whereas compounds cannot be separated. Now here we have the differences between mixtures and compounds. A table of these differences, actually. Number 1. In a mixture, component substances can be separated by physical means. But in a compound, constituent elements cannot be separated by physical means. So don't get confused with the constituent elements and the component substances. They do mean the same thing. The building blocks from which a mixture was made. This mixture can be separated into these building blocks again, but the compound cannot be separated into the building blocks it was made from. Number 2, mixtures' physical properties, that is color, density, and etc., are an average of those of the substances in it. Whereas in a compound, the physical properties are individual and not the result of its elements. They are something totally different. Normally, little or no energy is given out or taken in when a mixture is formed. Okay? And by energy, we mean light, heat, sound, and etc. But energy is usually given out or occasionally taken in when a compound is formed. This energy can be in the form of light, heat, and sound. Light is given out, heat is given out, and sound is also given out when a compound is formed, because a compound is formed whenever a mixture is heated. So when things heat, they make sound as well, like popping sounds, like sizzling sounds, and they may give off heat or take in heat, and they may give off light as well when they are heated. But a mixture is not heated. When we mix two different elements together, nothing happens. It's obvious, nothing happens because we know this for sure. When we mix salt into a different spice, nothing happens. But when we heat it, it starts bubbling, it starts popping, it starts sizzling, something like that, because it is changing into a compound now. Heat causes these mixtures to change into compounds. The fourth point is that a mixture's composition can vary, but a compound's composition cannot vary. The constituent elements are present in a fixed proportion by mass. So, we can make a mixture like iron and sulfur, and when we heat it, it forms into a compound. And it's so easy, we leave it out in the sun and it will reach to a temperature where it starts to react with each other and it can form into a compound. But no, forming compounds is not that easy. A compound's composition cannot vary. In the same way, the iron sulfide is a compound, and the constituent elements, iron and sulfur, are present in a fixed proportion by mass. To form one molecule of iron sulfide, we need one atom of iron and one atom of sulfur. So the proportions are equal to each other. And how much heat do we have to supply the elements for it to turn into compound to start the reaction? These things are very fixed. So to make compounds, the composition cannot vary. Whereas a mixture's composition can vary. We can add 2 tablespoons of salt in a cup of water, it will be salt water. And we can even add 1 tablespoon of salt in water, it will still be called salt water. So a mixture's composition can vary, but a compound's composition cannot vary. The elements are always present in a fixed proportion by mass. The fifth point is that a mixture's chemical properties are the results of the substances in the mixture, whereas a compound's chemical properties are quite different from those of its elements. So, the chemical properties we mean is basically how it will react with other elements. A mixture's chemical properties are the result of the substances in the mixture, like iron and sulfur. When they are mixed together, they form a mixture of iron and sulfur. And we won't call it iron sulfide because it's a mixture, not a compound, yet, because it is not heated yet. But the chemical properties of this mixture of iron and sulfur are the result of the substances in the mixture, are the result of iron and sulfur, okay? But in a compound, when they are heated, iron and sulfur, the chemical properties are quite different from the properties iron and sulfur have. So mixtures' chemical properties and physical properties are inherited from their constituent elements, iron and sulfur in this case. Sulfur may have a different sort of color and iron may have a different sort of color. When they both mix together, they form a color which is an average of the color of the two substances in it. The same is with the density, the mass. These are the physical properties. The chemical properties are the boiling point. So like I said, like we read before, that when salt is added in water, the boiling point rises because salt itself has a different boiling point and water itself has a different boiling point. But when they are combined together, the boiling point formed of that mixture is inherited from the boiling points of both the water and the salt. It's not different from it, it is inherited from the two molecules. But in a compound, the physical properties as well as the chemical properties are different from those of its elements. For example, we have iron and sulfur. Sulfur is purple in color and iron is blue in color. When we heat them together, the compound's color may be green or yellow, totally different from what its elements had. So, in the same way, it would have a completely different boiling point. It would have a completely different melting point, not related to the melting and boiling points of iron and sulfur. So, these were the differences between mixtures and compounds. Here you can see the structure of these. As you can see, a mixture is something like this, whereas a compound is something like this. In a mixture, you can see that we have two different elements. One is a purple one and the other is a green one. Let's take these as sulfur and iron. In this mixture, this sulfur and iron are still sulfur and iron, okay? They haven't turned into iron sulfide. They are still the atoms of iron and the atoms of sulfur. The purple ones are sulfur and the green ones are irons, okay? And so, whenever you see a mixture, the iron and sulfur are different from each other, as you can see. But they are just mixed together. These particles are so fine they get mixed together, but they are not chemically changed. The iron is still iron and the sulfur is still sulfur. Whereas in a compound, the molecules are something like this. The iron molecules and the sulfur molecules get chemically changed and they join together. The iron and sulfur join together, their atoms join together and they form this regular structure. Whereas in a mixture, there is no structure. The mixture is made up of two different elements, iron and sulfur, and they are not joined together. They are separate. In a compound, they are joined together. So, I think you've got the point what I'm telling you here. In a compound, the ions of iron and sulfur are chemically joined together in a regular arrangement. But here in a mixture, many atoms are mixed together. They are just mixed together, okay? So, here we have this chart. Matter, this is the general form of the entire universe, okay? Matter, this includes everything from mixtures, compounds, atoms, and elements to anything in the world, okay? So matter is distributed in two different things. One is mixture and the other is pure substance. In pure substance, we have compounds and elements. Elements are pure as well as compounds. They are pure because they are made up of only one thing. The elements are made up of only one atom and the compounds are made up of only one molecule. Then we have mixtures. These mixtures contain alloys and solutions. And mixtures are not pure, okay? In mixtures we have alloys and solutions. Solutions may be like salt and water solution, seawater. That is a solution, okay? And alloys may be something like brass, for example. Brass is an alloy. It is a mixture of copper and zinc atoms. Alloys are solids, whereas solutions are liquids. Like salt water is a liquid, sand water is also a liquid. But when we say alloys, we are referring to solids, like metals, like brass, copper. Okay, so I hope you've understood what I am trying to explain here. That matter is distributed into pure substances and into mixtures, which are not pure substances. In pure substances, we have elements and compounds. These are pure. And in mixtures, we have alloys and solutions. So this was it for today's chapter. This was our 5th chapter, Elements, Compounds, and Mixtures. We have successfully completed the learning objectives of this chapter, which were also very less, in which we had to define an atom and a molecule. We had to define elements, compounds, and mixtures, which I have explained in very detail, and I believe you have understood everything as well. And we've also listed the differences between mixtures and compounds. So the next chapter is going to be bonding and structure. So thanks for watching, and I'll see you in the next video.